Create 3 different expressions that are equivalent to 2x plus 11. Justify each of your equivalent expressions by using an area diagram with our algebra tiles, just like we did. Upload your expressions and pictures to the equivalent discussion board. Respond to 2 classmates' strategies for finding their equivalent expressions. It's interesting to see how each of you think, which is why I'm having you look at their strategy, try to make sense of it, and respond with your own questions or comments, etc. All right, let's write 2 expressions that are equivalent to 9x plus 15. I see that 3 is a common factor of both terms because 3 times 3x plus 3 times 5 gives me 3 times 3x plus 5. Let's make sure both expressions are equivalent through substitution. So let's use 10. In the original one, 9 times 10 plus 15 is 90 plus 15, which is 105. Doing the same with our new expression, 3 times 10 plus 5, so 30 plus 5, 35 times 3 is also 105. So again, just because they match doesn't necessarily mean that they're equivalent. Let's use a visual model to see what a factor of 4 would look like. So let's start off with 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 15. So here's 3, 6, 9, 12, 13, 14, 15. Okay, so we need 4 distinct groups here. So I'm going to start cutting these off so that I have 4. Oh my goodness, but this guy ain't going to be able to do anything. So we're going to have him hang out here. And then I'm going to start placing my individuals. Okay, remember we can't put them here, guys, because if I were to start doing that, we're going to overlap and it's not going to be, it's not the same. So we have to kind of put them under here where they create a nice rectangle, even though our X here isn't part of the rectangle. Okay. Oh boy, so I see then that I not only have an X left over, but I have 3 individual units. So when I took 9x plus 15 and I divided it by 4, we have 4 groups of 2x plus 3 plus an extra x plus an extra 3 units. So that would look like this if we were to write it out. So this is an equivalent statement to this guy up here. It seems weird, but it's true. Use the properties of operations to determine which expressions are equivalent to each other. I'll start with the one here on the left. I know then that we'll have 3 times 2x plus 3 times 6. That will give me 6x plus 18. All right, so let's move over to the next one. We will then have 4 times x plus 4 times 5 plus the x. This will give me 4x plus 20 plus x. I can group all of my x's together, giving us 5x plus 20. So right off the bat, the first 2 are not equivalent to each other. What about the third one here? I know that this will be 4 times x plus 4 times 3 plus the quantity 2 times x plus 2 times 3. This will give me 4x plus 12 plus 2x plus 6. Using our properties of addition, we can rearrange these so that we have 4x plus 2x plus 12 plus 6. So altogether we have 6x's and plus 18. So the first and the last expressions are equivalent to one another. Paige and Diego are having a debate about the following problem. If 3m equals 12, what is 5m? Paige thinks 5m is 14 because if I were to take 3 plus 2, I would get 5. So therefore, 12 plus 2 is 14. Boom, done. Diego thinks that 5m should be 20 because 5m is the same as m plus m plus m plus m plus m. Let's see what they're thinking about. Let's use a tape diagram to show who is correct. So we have 3m has to be the same amount as 12. Well, if I take 12 and divide it by 3, each m represents 4 units. So then what about 5m? Well, if each m is worth 4, we'll put 5 4s there. So 5 times 4 is 20. You can use substitution to determine if a given value is the solution of an equation. The solution of an equation is the set of values that makes the equation true. Mr. Williams is throwing his math class a pizza party. If he has 20 students and wants to spend no more than $65, use the table to decide how much of each item he should buy. Let's suppose that Mr. Williams buys 5 pizzas because the pizza serves 4 people. 5 pizzas times 4 people is 20 students, which is how many we have. 3 liters of juice and 5 boxes of cookies. The total cost then would be how much pizza plus the cost of juice plus the cookies. So if we're buying 5 pizzas and each pizza costs $8, we will have 8 times 5 plus the juice, which is $1.99 times 3 of them, plus $4.50 times 5 boxes. 40 plus $5.97 plus $22.50 gives us $68.47. Oh dear. Mr. Williams is over budget. What can he change so that he does not spend over $65? Well, if I take a look at the cookies, there are 5 cookies in each box. We would only need 4 boxes, not 5. Since 5 times 5 is 25 cookies, he would end up with 5 more. Let's do the same equation, except this time, let's use 4 boxes of cookies instead of 5. That would give me 40 plus $5.97 plus 18, which is certainly now less than $65. We can substitute values and evaluate expressions to make decisions and solve problems. The solution of an equation is the set of values that makes the equation true. Mr. Williams is now helping throw a pizza party for the entire 6th grade class on the last day of school. There are 200 students. How much will it cost to buy enough pizza? So notice that the cost is the same and each pizza still serves 4 people. So each pizza serves 4 people. 1 pizza for 4 people. If we have 200 people, how many pizzas will we need? Well, I know that 4 times 50 is 200. So 1 times 50 is 50. We need 50 pizzas. So the total cost would be 50 pizzas times $8 per pizza for $400. If equations are equivalent to each other, the value of the variable in each equation is also the same. So is 18 and 5/10 plus r equal to 26 and 5/10 equivalent to 6x minus 42? So I have a number line here. Let's represent from 0 to about there to be 18.5. And then I want to add a little bit more. We're not quite sure, but we need to add some to get to 26.5. So we can identify what that missing piece is by taking 26 and 5/10 minus 18 and 5/10. So the distance we must travel is 8. Using a tape diagram, 6 times how many is 42. So I'm taking 42 and splitting it into 6 groups. How many are in each group? So 42 divided by 6 is 7. These equations are not equivalent because the value of the variable is not the same. Let's see if 24 minus m is 8 5/10, equivalent to 2x equals 31. Again, I have a number line here. We'll start at 24. I'm subtracting an amount we're not quite sure of to get to 8.5. Well, I know then that 24 minus 8.5 will give us that extra distance. And that would be 15 5/10. Let's look at 2x equals to 31 using a tape diagram. 2 pieces of what gives me 31? So if I divide 31 into 2 different pieces, each piece would have to be 15 5/10. These equations are equivalent because the value of the variable is the same. Because equations show a relationship between expressions, we can use the relational meaning of the equation sign, equal sign, to find a missing value in an equation. Let's start with b divided by 8 is equal to 4. So we're not quite sure what b is, but when we partition it into 8 sections, each section has to be worth 4 units. Well, then I can take 4 times my 8 sections so that I know that b is equal to 32. Since multiplication is used to undo division, multiplication is the inverse of division. G plus 16 is 57. So what plus 16 gives us 57? Well, we can take 57, subtract 16, and that will give us our extra space. So therefore, G must be 41. Since subtraction is used to undo addition, subtraction is the inverse of addition. H minus 21 5/10 equals 13 5/10. So that dotted line represents the subtraction piece. Starting from the whole piece, we're going to take away the 21 5/10. We can add those two pieces together such that h is equal to 35. So since addition is used to undo subtraction, addition is the inverse of subtraction. So addition has the inverse of subtraction, and subtraction has the inverse of addition. 5x is 115. 5 copies of what gives us 115? So 115 divided into 5 groups is how many? That must be 23. Since division is used to undo multiplication, division is the inverse of multiplication. Just like adding and subtracting are inverses of each other, the same is true with multiplication and division. Inequalities show a relationship between expressions. We can write the inequalities using the symbols less than, greater than, less than or equal to, or greater than or equal to. 2 bunnies are less than 5 bunnies. So 2 is less than 5. However, 2 less than 5 is actually a subtraction problem. So 5 subtract 2. There is fewer than 3 is fewer than A. So 3 is less than A. Versus the wording 3 fewer than A would be A minus 3. W was more than negative 10. So W is greater than negative 10. Versus W more than negative 10 would be negative 10 plus W. 89 is larger than 87. So 89 is greater than 87. 89 larger than 87 would be 87 plus 89. Max loves his job. His fastest speed is almost, I should say jog, not job, jog. There we go. His fastest speed is almost 6 miles per hour. Well, he's not quite there and he's not over it. So his speed has to be 6 has to be less than his speed. Today's temperature is 10 degrees less than yesterday's temperature. 10 degrees is less than yesterday's high.